Lab Guy here. Today we're going to talk about the video preamplifier's physical construction. The video amplifier is very sensitive to noise. It must be shielded. It must be located as close to the output connector on the monoscope tube as possible. This means that the preamplifier must be positioned at the very top of the stack of rings that I built that supports the monoscope tube. I didn't think this through clearly. In the original configuration, I had a BNC connector built into the top lid. I planned on running a cable from that connector down to the primary chassis and into the video amplifier board. This was an extremely bad idea, as was pointed out to me by my friend Howard. So I had to step back, think it through, and design a new part for the top of the stack. So the stack has grown by 52 millimeters now. I designed and printed really a new housing to contain a shield canister which will contain the video preamplifier stage. That part came out very well and then left me in the quandary, how the heck do I get the wires from this thing down the stack and into the chassis without picking up a ton of interference from the deflection yoke? I had a mindset that the wires must run down the inside of the Faraday shield on the stack. Well, this brings us to the old adage of think outside the box. So, in the new configuration, the preamp housing, which now sits on top of the stack, will be connected by a cable that runs down the back side where it's not so visible, the back side of the stack, and plugs into the top of the aluminum primary chassis. I built a cable this morning with a 5-pin DIN connector. The DIN designation refers to a German standards institute from back in the late 50s or 60s. These plugs are used everywhere. This is a standard, easily obtained, very low cost plug. So what I've done is in this cable I have installed a 4-conductor wire. It's in fact, what did they call it? Low voltage wiring wire. Standard 4 colors, red, black, green, and yellow, like telephone wire. It's 22 gauge stranded wire, and in addition there is a coax, a 75 ohm small diameter video coax, which won't be a problem for us because we're only going that far. This will plug straight down behind the stack and will loop over and go into the new video preamplifier, which sits on top of the stack. Not much to look at on the outside. Hi, Chief. Inside is a metal can, which I've already shown you, with the circuit board inside. The lid of the can is attached to the original top cover, so we don't lose that. That aluminum screw I showed you is from an old camera tripod with a 1/4-20 thread, and with a simple nut it holds the original lid of the canister to the original copper sheet. A new one will be made for the back side of this unit, and the top cover is simply held on by friction of the canister lid. Very simple, pops right off, and it must, for us to change the tubes. Now the screws go into these recessed pockets, which are hard to see for me on the viewfinder here, and protrude through and screw into the original standoffs that originally held the lid. The big innovation is the pogo pin, which I showed you last time around. It is installed. It is exactly the right length. It is dead center. Even I'm impressed, and I'm not easily impressed by my own work. It still pogos and is soldered in the dead center of the of the circuit board, and is insulated on the outside by a rubber grommet where it goes through the can to prevent it shorting should it get knocked to one side or the other. I tried it for fit. It nails the center contact of the picture electrode on the monoscope tube perfectly. Bear with me while I grin and bear this myself. This is, I'm blown away by how fast I was able to design this design this 3D plastic. This is the result of changing from white filament in the printer to black filament. So the first 2 or 3 feet of printing was still white, and then it slowly turned to black. Because this is 2 halves, the plastic part, each half took 10.5 hours to print. I had to listen to that printer night before last until 4 in the morning, printing away, making the first half. And even though it has this little white error in it, when it's installed it will not be seen. We're going to live with that because I didn't want to spend yet another half day printing a third piece and wasting this much plastic filament. So yesterday all day the second half was being printed. They're joined together with a nut and bolt on each side, and we are now ready to proceed to electronic assembly. The last step needed for adding the cable is to make an access hole in the appropriate location and bring it into this can, preferably with yet another connector at this end, so this thing can be disassembled for service and to make it easier to change the tubes. Because I want to use the Chief to show both of my monoscope tubes, and for those collectors who have a monoscope tube, when we meet up in person and I bring the Chief with me, we can test your monoscope and see if it works and see what's inside. Sorry about the background clutter. I'm not going to take the time to set this up. I would rather be building on this thing. So you're looking at the original top support ring and the new preamp assembly. Yes, it looks like rolls of duct tape, I know that. So this assembly will be attached with 1¼ 632 American Standard thread screws. The 2 halves are held together with 632 screws, 1 on each side. And the interconnect cable, when plugged into the primary chassis, we're looking currently, this faces the back side over here. This will come up and curve over into the unit. So that is how that is to be installed, and then the lid, as you saw, just simply fits with a friction fit. So now enjoy some video of the installation of the mate to this guy, and then some of the printing of the plastic parts. Lab guy out.